All right, so we're going to do more practice with sine and cosine. We're just going to relate it to like a real world situation, which means you're gonna have to just put units in your answers and stuff like that. So I wrote this on here again. If you want to always block off the part that's the trig function, that's what comes from the unit circle. And then you just have the amplitude out front and then plus or minus whatever the vertical translation is at the end. Amplitude is absolute value of A. I'm just reviewing this. We did this last time, but it's review. Never bad to go over it again. The period is 2 pi divided by B, but you have to absolute value that as well, because again, those things are distances and a distance can't be negative. Your vertical translation is D, that's how much you moved up or down. And then the range. D is the center, and then you went down A and up A. So it is going to be D minus A, comma, D plus A. So you find that center, and I usually just dot it in because it helps if you have a visual, like just draw it, and then you just add or subtract whatever the amplitude was. All right, so let's read the first one. I know there's a lot of words there. I'll read it to you. A signal buoy in the Chesapeake Bay bobs up and down with the waves. Okay, like use your imagination. Are you imagining some waves going like this? Okay. You with me there? Or are you writing on your hand? All right, so it's bobbing up and down. The height is in feet, so just be aware of that. And then do we have a time? Time is in seconds. Just be aware of the units because you're gonna have to put that in your answer. And again, if you wanna block off the part that is just the trig function to keep that separate, then you can do that. All right, it says the height varies between 1 foot and 9 foot. So that's the minimum and the maximum values that we're given. So letter A, what is the period of the function and what does that mean in the context of the problem? So how do we find the period of the function? Before we get to the explaining, because I know that's the scary part, how do you find the period of the function? 2 pi over B. What is B in this one? Yeah, 4 pi over 7. It's whatever, well, I usually say it's whatever's in front of X. For this problem, it's T because we're talking about time, but over 4 pi over 7. I realize that looks terrifying, all right? But when you divide by a fraction, what do you do to it? Flip it, all right? So it's gonna be 2 pi times, you multiply by the reciprocal, 7 over 4 pi, and that will already not be so bad because what happens to the pi's? They cancel out. So it's gonna look nasty for like a second, but then it won't be so bad. So we're gonna do 2 times 7, which will give us what? 14 divided by 4, and that'll be what? We'll both divide by 2, so 7 halves. Did I do something wrong? 2 times 7 is 14 over 4, 7 halves. If you want that as a decimal, does anyone know what 7 halves is? 7 divided by 2? Oh, close. 3.5. So we found the period of the function. You could leave it as 7 halves. I was just bringing it up as the decimal. Then we have to explain what that means in the context of the problem. The period is how long it takes to do 1 full cycle. What was our time measurement? You just have to put the units in there. Time was in seconds. Here's your explanation. It takes 3.5 seconds to complete 1 cycle. Anytime you're asked to explain what the period means, that's the answer. I can't change it. It's like a definition. It's the time it takes to complete 1 full cycle. So that means the buoy goes, I love that word buoy, by the way. Isn't that like the best word? Well, it goes up, it goes down, and then comes back to the center. It's how long it takes to do that 1 full cycle with the wave. And then letter B says, what is the value of A? Did you notice they didn't give us A? All right, we're gonna find that. I would draw a picture. Where is the center? Good, 5, why? How'd she get 5? Because that's correct. Yeah, it's what's added at the end here. That's your D value. So your center is 5 feet, and your wave does something like this. Just draw it. Like in your picture, doesn't have to be perfect, okay? Like just good enough. Now they told us what the maximum and minimum were. What was the minimum value? This is 1 foot, and then the maximum 9 feet. So what they asked us was what was A? So that means what is this distance? So what does A have to be? If you're centered at 5, then you go from 1 to 9. What is that distance from the center? 4 feet. Draw a picture. It helps a lot. I just always draw one. All right, in a city, the amount of pollution in the air becomes greater during the work week. Does this make sense? It would be more during the work week when like all the businesses are going and people are driving their cars. And then on the weekend when everyone chills at home, like pollution would go down. Do you guys remember reading about that? Like when COVID and shut down everything and pollution went way down in the air because no one was driving their cars anymore. Anyway, it would be cyclic. Pollution would go up during the week when everybody's there and then go down over the weekends and then go up and down. So it's going to be a wave, all right? If you want to block off the trig function part of it, you can. I just do this because I think that helps. This is giving us the percentage of pollutants. So our units are kind of like percent, like this is the percentage in the air. And then time is measured in days. So just like I circle those things, just be aware of what your units are. And our time is starting at midnight on Saturday night. So like when Saturday turns into Sunday, is that making sense? Like midnight Saturday, and then it becomes Sunday after that, okay? What is the period of the function and what does that mean? All right, it's gonna be 2 pi over what? Pi over 3, yeah, it's whatever, I say it's whatever's in front of the x, in this case, it's t, but over pi over 3. I realize that looks awful, but we're gonna flip it and it's not gonna be so bad. So it'll be 2 pi times 3 over pi, just multiply by the reciprocal. The pi's cancel, and so what do you get? 6, good, 2 times 3 is 6. Now you have to write a sentence. It's gonna be almost the exact same sentence that we wrote for this one. We're just, instead of 3.5 seconds, we're gonna change that to what it is in this problem. So it takes 6 what? Days, good, to complete 1 cycle. No, let me talk about that for one quick second. I realized that there aren't 6 days in a week. How many days are there in a week? I tried to make the problem where it came out to 7. 7 is a very awkward and horrible number to deal with, and it totally made the rest of the problem very, 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 very not fun. Do you get what I'm saying? Can we just pretend there's 6 days in the week for this problem so that the math will turn out? Like I tried to do it and it was horrendous, okay? Are you with me? Pretend there's 6 days in a week. Makes the problem way easier. All right, what are the maximum and minimum percentages of pollution in the air? Here's where I would draw this. Where is our center of pollution? 30, good, 30%. And it's gonna go up and come back down. Or actually, I think this one goes down first because it's negative. Do you see that negative out front? It's gonna end up going down first and then up. So we start at 30, and then it's gonna go down 12. Our amplitude is 12. It's going to go down 12. So 30 minus 12, be 18. And then back to 30. And then it's going to go up 12. So 30 plus 12, 42, and then back to 30. Put that away. Away. It's distracting me at this point. These notes are very short. You're going to be okay. So what is the maximum percentage of pollution? 42%, and the minimum is 18%. Just draw a picture, it'll help. Now C is when do those happen? Our picture doesn't show us the times when those happen. I would make a chart, or I guess I was gonna write X, but I'll put T for this since we're talking about time. And I guess P of T, P for pollution is what's in the equation there. And I would just do the chart exactly like we just did on your quiz review and fill it in. So you start with the phase shift. This one doesn't have a phase shift. There's nothing added or subtracted in there. So we're going to start with 0. And then what was the period? Because we already found that in part A. 6. Do you see how if it was 7, this would be totally obnoxious? I mean, I wanted to make it an even number. What's going to be halfway in between those? 3. Good. See, that made the problem a whole lot easier. Halfway in between 0 and 3 would be 1.5. So like 1.5 days. And then halfway between 3 and 6 be 4.5 days. And then these values, we already wrote them, really. If you just want to look at the little picture we did, it starts at 30, goes down to 18, back to 30, up to 42, and then back to 30. So we already found those. I just kind of filled them in on the chart. Wait, question? Oh, okay. So here's the minimum and here's the maximum. So the question is asking when they happen. So let's do the minimum first, since it shows up first in the chart. Minimum is at 1.5 days in. Now this is a little tricky because we have to think about where we started. We started at midnight on Saturday night. So if you go one whole day, that would take you to midnight on Sunday night. And if you go another half a day, that would take you to noon on Monday. Are you following me? Like it would be midnight Sunday, go, okay, thank you for head nodding. So the minimum is at noon on Monday. You just kind of have to count it out in your head. And then the maximum is 4.5 days into the cycle. So again, we started at midnight on Saturday. Okay, so 4 days. Midnight on Sunday, midnight on Monday, midnight on Tuesday, midnight on Wednesday. And then if you go another half a day, that would take you to noon on Thursday. Good, thank you. And then the last one, at time 3 days, and then I wrote on midnight on Tuesday night. What is the percentage? Well, we already made a little chart. At 3 days in, what's our percentage of pollution? 30%. I'm going to have us just keep going and finish this because the notes are real short. I'll give you my copy when we're done. Okay. All right, so this one's about the blades of a wind turbine as they spin around. Imagine this spinning. The end of it is going to go up and then come down and then go up and then come down. So if you chart that, it's a wave. It's going to go up and down and up and down. All right. So let's block off the part that is the trig function. That's this part. And so theta is in radians, right? Because we've got like pi in there. So theta is in radians and our height is measured in meters. So height of the turbine is in meters. So again, letter A, what is the period of the function and what does that mean? You would put 2 pi over whatever's in front of the, in this case, theta. There's nothing there, so what is it? It's, yeah, good, it's over 1. You guys are jumping straight to the answer. You're like, we've got it, Miss Gold. 2 pi. So you're gonna write the exact same sentence as we had here, except instead of 3.5 seconds, we're gonna say 2 pi radians. It takes 2 pi radians to complete 1 cycle. Which makes sense, that's once around. And the turbine is circular, it's going around in a circle. All right, what are the maximum and minimum heights that the blade reaches? I would draw a picture. Where are we centered? 40. And again, like I said, you're not gonna have questions exactly like these on the quiz, but do you see how we're still reviewing the same stuff that's gonna be on your quiz? Like it's all the same material, right? We're centered at 40, gonna go up, go down, and come back. And our amplitude is 8.5. So what's gonna be up here at the top? 48.5, and then subtract 8.5. Oh gosh, was that 31.5? All right, so our maximum is 48.5 meters, and our minimum is 31.5 meters. So yeah, just draw a picture. You just add and subtract whatever the amplitude is. So explain what the value of 40 meters means in the context of the problem. 40 is where it's centered. So think about this, and I'll point to it. If we're talking about where this is, as it goes up and then goes down and then comes back to the center. If it's centered at 40 meters represents what part of that picture? Like if 40 is where you're centered, it's going to go above 40. Yeah, like this amount would be 40 meters, right? Because it's going to go up above 40 meters. It's going to go down below 40 meters. But like, yeah, the center, like what you guys were trying to say, the center there is at 40 meters. So 40 meters would be like the height of the turbine. Like, I like how you said it. You said the center. It's where the center is. That's another way you could say it. Yeah, because that's literally where you're centered. And so D is explain what the 8.5 means. Well, if it goes 8.5 above and then 8.5 below, what does the 8.5 represent? Yeah, good. How long the blade is. This would be your 8.5 meters. So 8.5 meters is the length of the blade. Are you knocking on our wall over there? All right, one more. If you want to block off the trig function to see what's inside and what's outside, you can do that. You don't have to. I'm just throwing it out there as a suggestion. All right, so a child is at the wave pool. Have you ever been to a wave pool? They're super cool. Ride the waves up and down. Anyway, it's like the buoy, except this one's about a child riding the waves up and down. That's the model. Time is in seconds, height is in feet. So just be aware of what your units are. What is the period of the function? All right, you're going to put 2 pi over 4. So that would be 2 pi times 4 over pi. Pi's cancel, and what do you end up with as your answer? 8. Now you have to write the sentence. It takes 8 seconds to do what? To complete the cycle. Notice how I had you write that for every question? I do that whenever you know I'm going to ask you like a question like that on your test. Like I'm coaching you to just write the same thing over and over. So when you get the test in front of you, just write that sentence. That's the answer. Like I can't change it. That is the answer. The only thing that'll change is the 8 seconds. It'll be whatever is in the problem. All right, maximum and minimum height reached. Let's draw a picture. Where is the child centered? 7, good. She's gonna go up, go down, come back. And what is our amplitude? 2. So the height up here would be 9, down here would be 5. So maximum is 9 feet at, and we have to say when that happens. Let me come back to that because I tend to like to make a table for that. So the maximum is 9 feet at, we'll come up with that. Minimum is 5 feet at, and then we'll come up with that. I would just make a table exactly the way you're going to do on your quiz. This was X and Y for this one. Like I would just fill it in as a table. So what was the phase shift? Look back at the problem. We moved right 1, good. So we're going to start at 1. And then look back at part A, what was the period? 8. So 1 plus 8 is 9. Then you have to break it down to what's halfway in between. So halfway in between 1 and 9. You can even draw a number line and like count to the middle. Halfway in between 1 and 9. Or you can count on your fingers. 4. It's 5. Okay, there we go. I was like trying to count it. I'm like, oh, 4 doesn't seem right. 5. Okay. And then halfway between 1 and 5, 3. And then at that point, like you realize you're just using all the odd numbers, just counting by the odds. And then the y values, we already found them. Look at your picture that you drew. It starts at 7 and then goes up to what? 9 and then 7 and then 5 and then 7. Again, I hope that this is like sort of just a reinforcement of what we've already learned. I hope you're like, oh, okay, like I'm starting to get it better. It's just more practice. So the maximum happens at what time? 3 seconds, good. And the minimum happens at 7 seconds. So draw a picture and just make a table, it helps. And then because we already did all this work, we can answer this question. Just like the pollution one, it said, what's the percentage of pollution at a certain time? Well, we already had our table and we could just look at it. What is the child's height at 5 seconds? 7 feet. You just already have it on the table, so you're good to go.